So today, Lefteris will be speaking to us with a speech entitled Best Practices for Serverless Developers. This will provide architectural best practices, optimization, and useful shortcuts that everyone can use to build secure, high-scale, and high-performance serverless applications. Let's all welcome Lefteris. The stage is yours.
Thank you so much. Hi, everyone. I hope you had a good lunch. And I hope you're still hungry to listen to my session and learn more about best practices, optimizations, and techniques you can take to level up your serverless development game. Now, before we start, please raise your hands if you're using serverless development on your day-to-day job. So like 5 hands, right? And now raise your hands if you know nothing about serverless development on AWS. All right, perfect. So a few words about me. I've been a senior solutions architect at AWS for 3 years now. I'm also one of the few hundred serverless experts globally. So we help customers with serverless architectures. In 2019, I co-founded a startup which I built solely on serverless, and in just 10 months, I built the whole platform, and I got awarded by AWS $10,000. I'm also a public speaker, and in the last 2 years, I've presented to more than 20 events, including the biggest cloud event of the year, which is AWS reInvent in Las Vegas. And in fact, next week, I will be traveling there, and I have 3 sessions to present in reInvent. So last year, I wrote my first book, which is called Mastering Event-Driven Microservices in AWS, and it has everything around serverless. You can find it on Amazon. It has good ratings as well. I also started my creator journey, and I built a newsletter called The Cloud Engineers in the beginning of this year. Now it has something like 3,000 subscribers, so you can find it on Google as well. And I have mentored a few hundred people break into cloud, and I had the honor to be featured in Times Square as well. Right, so I'll start by a study by Deloitte, which showed that 80% of developer time is spent on operations and maintenance. That means that only 20% of the time that developers spend is really focused on the business value and the code. And companies don't really want that. That is why serverless adoption is growing too fast. Now, serverless enables developers to really focus on what matters, on the business value and the code for the company, and not the infrastructure management. Now, with serverless, the cloud provider is responsible to provision the infrastructure and to also maintain it. With serverless, you get automatic scaling. You don't have to do anything to go from 10 requests per second to 10,000 requests per second. This is all done by the serverless services. Also, serverless services, they follow a pay-per-use model. So if you are not using the serverless services, you pay 0. And finally, due to the nature of serverless, they are highly available because you don't really control the servers, and they also have built-in security, so you don't have to do anything around security. And what does that mean? That means that you can build a proof of concept and get to market very, very fast, right? Like I did with my startup. I built my MVP in just 3 months with serverless, and you can do the same. It's also highly performant, and they have automatic scaling, and you can scale up to many thousands of requests, and we'll see what that means. And we also talked about the low cost that we have with serverless services and the security, which is by design. So what customers are really building with serverless on AWS? You can do a few things. You can automate stuff, like my server will go down and I need to get notified through an email, through a Slack message that something has happened. You can automate stuff. You can do data processing. So for example, you can move data from a source to a destination, you can clean the data, you can transform the data, all sorts of data processing stuff. It's perfect also for web applications, especially if you're building microservices, it's ideal to have serverless. And finally, you can do a few things around machine learning and especially inference and not really training with serverless. Now, the question is the following. So what AWS service comes to your mind when you hear the word serverless? Yes? Correct. And the correct answer is AWS Lambda. Now, AWS Lambda was the first serverless service that was invented in 2014 by AWS. And the term serverless was coined at that time, in 2014. But if we go back in history, we will see that the cloud was born serverless. And why is that? In 2004, AWS launched the very first service, which is not servers, it's not EC2 instances, it was Amazon SQS, a serverless queuing service which was the first invention. The next service that was launched was Amazon S3, again, a serverless storage service. And then AWS invented serverful services like EC2. But really, the term serverless was coined when AWS Lambda came out in 2014 because it was more towards serverless developers, whereas SQS and S3, you cannot really develop on them. Now, what is AWS Lambda? AWS Lambda is a serverless compute service where you can write your code in your favorite programming languages. It supports Node.js, Python, Java, .NET, and many more, right? You write your code, you deploy it to AWS, and it just works. You don't really care about maintaining or handling any servers. Now, AWS Lambda has to be triggered somehow. It can be triggered through an API, in Amazon API Gateway, for example. It can be triggered if something changes in Amazon S3. So if I upload a file, I can trigger a Lambda function and do something. It can be triggered if I change something in my DynamoDB database, which is a NoSQL database in AWS. So an AWS Lambda function has to be triggered somehow. And it has only one entry point, which is triggered. And what do we do with the Lambda functions? We write our code. We write our business logic, right? We can save something to the database. We can retrieve from the database. We can call like an external API or a whatever downstream service. So now you will ask me, since you said that serverless is ideal, it has like automatic scaling, like the pricing is very good, you don't pay for idle capacity, right? Why isn't everyone using serverless in all the use cases? And the question is because of a scary word, which is called cold starts. Who knows what a cold start is? Right, so like 20 hands. Perfect. Now, due to the nature of serverless, and because serverless can scale from 0 to whatever request we have, then what 0 means is that actually nothing is running. We don't have any servers to accept our requests. And because we need to start servers in the background to trigger our Lambda functions, then this initialization time is called a cold start. Now, the first customer conversation that we are having is around cold starts. Everybody says, I don't like serverless because it has cold starts. Now, this initialization time, the cold start, varies from like 100 milliseconds up to 8 seconds, let's say, okay? And that really depends on the programming language that you use. For example, Python, Node.js, or Go are the fastest ones, and compile languages like .NET and Java are the slowest ones. But the good news is that cold starts occur only in less than 1% of production invokes. But let's dive into what cold start is and how actually it occurs. So we write our code in Lambda, we deploy it to AWS, and the first time we have to trigger AWS Lambda through an API, let's say, what Lambda service does behind the scenes, it creates a new execution environment, and that is actually a micro VM, which we call Firecracker. It downloads your code, your jar file, whatever you have, right? It starts up the runtime, the JVM, for example, and it runs anything you have outside the entry point of Lambda, which is called the handler method. What that might be, you connect to a database, to an API, whatever, it does all those initializations. And that init time is what we call the cold start. Now, when we create a new execution environment, the next time it's already warmed up and we don't really have another cold start. So if we're constantly triggering a Lambda function, we will not see any other cold start unless we have another concurrent request, because one execution environment can only accept one request at a time. So if we have 10 requests, let's say at the same time, we need 10 execution environment, and that means 10 cold starts. Now, in the following slides, what I'm going to do is I will show you some tips to really optimize your Lambda performance, the cold start, the whole duration, because that is what matters a lot for companies, to really reduce the latency of their Lambda functions. Now, this is a very typical example of using AWS Lambda functions. So you have an Amazon API gateway as the front door, serving all the APIs, and then you're just routing to different Lambda functions, and the Lambda function is calling a downstream service, right? But if you're only using AWS Lambda to transport the data from Amazon API gateway to the downstream service, does it really make sense to use Lambda and have a cost for it? No, it does not. So what we can do alternatively is we can use the Amazon API Gateway direct integrations, which has with many, many AWS services, for example, DynamoDB, step functions, SQS, and many other services, and we can replace AWS Lambda, right? So if you're using Lambda just to transport data and not to transform data, then you don't need to use it at all, okay? The same thing with step functions. So step functions is a serverless orchestrator service in AWS where you can create like your state machine and you have like a series of steps it goes through, right? And if what you're doing is actually moving data from one state to the other, then what you can do is use the step functions SDK integrations. So you can directly call other AWS services and you can replace Lambda, right? The same with other services as well, and the last example I'll show you here is with Amazon Event Bridge. Now, whenever you change something in Amazon DynamoDB, whenever you insert something to the database, you can trigger a Lambda function, and then you can send that event to Amazon Event Bridge. And here, you don't really need AWS Lambda, right? You can use a feature of Amazon Event Bridge, which is called Event Bridge Pipes, to actually move the data across DynamoDB to Event Bridge. Okay? So the first optimization technique I want to show you here is whenever you can replace your Lambdas with direct integrations, it's the best. Okay? And something I usually talk in my book that has a few optimization techniques for serverless applications is I say that one of the best optimizations for Lambda is not to use Lambda at all. Another thing that we're talking with customers about is what should my Lambda function contain? So we see like two things here. One is people, like developers that take like monoliths, and they bring those monoliths into Lambda. We call that a Lambda leaf. Okay, so we have one Lambda function having like several functionalities in it. And the other one is what we call micro Lambda. So we have one Lambda function per functionality. So in this case, we have, like, say, 10 different Lambda functions. So we've seen that the best is to take the best out of those both worlds. And what that means is the best is to group your functions around the microservices architecture and the bounded context. For example, you might have all the functionality related to the user, let's say, functionality, to the user table, let's say. Okay? So you can have like your get users in one Lambda function. And why would I do that? Because I would have one Lambda function serving two functionalities. So the first time, I will have a call start, and the second time I will not. If I had two Lambda functions, I would have two call starts. Okay? And operationally, reducing the number of Lambda functions is good. Okay? Because in a microservices architecture, you might end up having thousands of Lambda functions. Now, other optimization, other grouping functionalities that you can do here is based on shared dependencies or downstream dependencies or whatever. So consider grouping your Lambdas to reduce the number of call starts you are incurring. Now, when I create a Lambda function, what I can set is only the memory. I cannot set the CPU, I cannot set the network. I can only configure the memory. From 128 megabyte up to 10 gigabyte of memory I can have. Now, as I increase the memory, the CPU and the network proportionally allocates. So if I set like 10 gigabytes of memory, I can get up to 6 cores. Okay? So the more I increase the memory in my Lambda function, the better performance I might get. And now you'll ask me, if I increase the memory, will I not pay for more? We'll see. Now, if I go to the AWS cost calculator and I see what is the cost around an AWS Lambda, I will see that it's estimated for the memory you allocate and the duration of the Lambda function. Okay? So if I can set 2 gigabytes of memory and my Lambda function takes only 1 second, compared to another Lambda function which is 1 gigabyte and takes 2 seconds, then they are equally expensive. Okay? So if I can lower my whole duration of my Lambda function by increasing the memory, then I would have to do that. Now, and how do I do that? By using a tool which is called Lambda Power Tuning. And what that does, it's an open source tool which runs a step function state machine against different memory configuration you send as an input. And at the end, it gives like this cool graph which shows like the lowest cost and the fastest invocation time. And then I decide what I want to set. So configure the proper amount of memory is the first thing you should do when dealing with Lambda functions. The second one, the other one, the fourth one, let's say, which is a bit obvious, is I need and I have to minimize the deployment size of my Lambda function. Because whenever the execution environment downloads my code, it has to be minimal, right? So do not use like big framework or like fat jars, as we say in Java, right? If you want to only include the DynamoDB SDK client, let's say, do so. Do not like include the whole AWS SDK, for example, right? So always try to minimize the deployment size of your Lambda function, because you will see an improvement in cold starts as well. Now, another feature I want to talk about is called Lambda Snapstart. And what that does is something very, very clever. Whenever I deploy my Lambda function to AWS and I have enabled Snapstart, what it does, it takes a snapshot out of this function and it saves it to memory. And whenever I need to trigger my Lambda function, it restores the snapshot from the memory, which is very, very fast. And what I get out of it is I get up to 10 times faster startup performance, which is great. And I incur cold starts only once when I deploy my Lambda function. Now, Lambda Snapstart is supported by 3 languages, Java, .NET, and Python. And because the first language that was supported was Java, it comes at no cost. But for .NET and Python, it comes at a cost. And typically, you have to do no-code changes. You just enable Snapstart on the AWS console or SAM or whatever CloudFormation or Terraform template you're using. Okay? So we always tell to our customers, especially Java customers, always use Snapstart. For Python and .NET, they have to pay and they have to consider it as well. So why are we saying all those optimization techniques, right? Is it only to just reduce the whole duration of our Lambda function? No. It's also to improve the scaling of Lambda function. And I'll show you why. Now, let's understand what concurrency is in AWS Lambda. So as we said, every time we have a new request, we have to create an execution environment, a VM, right? And if we have concurrent requests, because every execution environment can handle only one request, we need to create more. Okay? So in this example, we start with 3 requests, then we go to 4, 5, and so on. Okay? And that is the concurrency. How many execution environments we have to accept our requests. But it's important to note here that concurrency does not mean how many requests we can accept per second. And why is that? There is a formula which shows that the concurrency is equal to the average requests per second. Let's say we have 1,000 requests per second, multiplied by the average request duration in second. Let's say 1 second duration for a Lambda function. Now, the default Lambda concurrency per region for your accounts is 1,000. And let's do some math and see how many requests per second we can get from this example. So the concurrency is 1,000. Our Lambda function takes 1 second to complete. How many requests per second can we have? 1,000, right? But if we go through a few optimization techniques that we saw before, and we manage to decrease the duration of our Lambda function from 1 second to 0.1 seconds, how many requests per second can we have? And the answer is 10,000, which is massive. Now, the last thing I want to talk about is what usually people ask me. So how do I get started with serverless? So I would like to introduce you to SAM, which has like a very cool logo here. Now, SAM stands for Serverless Application Model. And SAM comes into 2 parts. One is you can write your infrastructure as code. So whatever you're doing with Terraform, whatever you're doing with CloudFormation, you can do it with SAM. And with SAM, you can build serverless applications in less code than you would do with CloudFormation on Terraform. For example, you can write like in 15 lines of code and create a Lambda function with an API, which is pretty handy. And the other part is the AWS SAM CLI. Now, CLI has commands for you to do like local development, debugging, building, packaging, and other things as well. Now, let's see an example how I would start with SAM. So, you use your favorite IDE, like, I don't know, Visual Studio Code, IntelliJ, whatever you're using, we don't care. You download SAM, and you go to your project and you do SAM init. And what that would do, it would create like the code base there, where it will have you choose, like when you do SAM init, you choose from a template, whatever language you want to use. And then you have the app.py, which is your Lambda function there, which has no business logic at all. And a Lambda function is very simple, as you see. It has an entry point, which is called whatever you want to call it, right? And you do your business logic, and you just return a JSON, okay? Now, when you do SAM init, you also see that it creates a template YAML file at the bottom. And what that has, it's the SAM infrastructure as code. So you see in 15 lines of code here that you create a Lambda function and you also create an API in front of it. As soon as you initialize your project and you write your business logic in your Lambda function, then you can also test it locally. So you can test Amazon API Gateway locally. And how would you do that? You run the SAM local start API command. You give it a port, and it actually exposes your local host with this port, and it uses Docker behind the scenes, so you need Docker for it. And you can do like whatever curl commands, or you can use Postman or whatever to actually test your local function. Yeah. And you can also debug it as well. Okay? So here I'm using curl to actually do and call the API Gateway API. And the fourth thing you would do, as soon as you have like your serverless application up and running, you are going to build it. So SAM build will build your code. If it is Java, it knows how to build it. If it's Python, it knows how to build it, whatever. And then you just do some deploying, you deploy it to AWS. So in a few hours, you can create serverless applications. You can do POCs. You can build your project, your startup, whatever, in just a few hours, deploy it to AWS, and you don't have to pay for anything if you're not using it, which is amazing. Now, if you want to learn more about serverless, there is a great resource, which is called Serverless Land. It has many code examples, many white papers, documentation around serverless. So please visit this website. AWS and we are maintaining this one. With that, I want to thank you. And this is the QR code of my LinkedIn profile. If you want to connect with me, I will be happy to have a chat as well. So please do so. I have in my LinkedIn profile my newsletter as well, if you want to subscribe to it. I write practical cloud articles like every week, and you can also find my book there. Thank you.